Scientists have real proof, not just a guess. Scientists already have solid proof, not just an idea or theory, about something huge. The reason you probably haven't heard much about it is because it's really uncomfortable. Even the experts who discovered it aren't sure what to do with it yet. There's a real scientific paper, checked by other scientists, repeated many times, and mentioned in over 4,000 other papers. It shows that the world you experience right now, the one that feels totally real, might not be the bottom layer of reality. It's not poetry, it's based on actual measurements and math. I want to explain the proof step by step, what the experiment showed, why it works, and what it means for you. By the end, you might look at your own hand differently. Here's the plan. First, I'll show you the key experiment in simple terms and what it breaks. Then I'll explain how 3 different areas of science all point to the same surprising idea. Finally, we'll talk about what this means for you personally. Look at your hand right now. Go ahead, look at the back of your hand. Feel its weight, see the skin texture, the little lines on your knuckles, how light hits it. It feels solid and real, right? Like the most real thing ever. But physics says that feeling of solid stuff isn't the basic foundation of the universe. Instead, it's more like a picture or a rendering on a screen. The big question in serious physics for the last 40 years isn't if this rendering happens, it's what is doing the rendering and why. Lisa Randall's question. Before Lisa Randall became a physicist working at Harvard on big space questions like extra dimensions and dark matter, she asked a simple thing many of us wonder about at night. Why does anything feel like something? Why does touching your hand feel like real contact instead of just data? This used to be a philosophy question. Now it has physics answers. The big experiment from 1982. In 1982, in Paris, a scientist named Alain Aspect did an experiment. It tested quantum entanglement. Simple version, take 2 tiny light particles, photons, created together. They become linked like one thing even if you send them far apart. Measure one and the other instantly changes too, even if they're too far for any normal signal, like light speed, to reach in time. Einstein hated this idea. He called it spooky action at a distance and thought there must be hidden instructions inside the particles. He believed the world is local, things only affect nearby things, and real, things have fixed properties even when no one's looking. The experiment proved Einstein was wrong on this. The particles behaved in a way that no normal, local, and real universe could explain. This isn't a small glitch, it's a clear mathematical proof. The holographic idea. Another big clue comes from black holes. Scientists like Jacob Bekenstein and Stephen Hawking found that the information a black hole can hold is based on its surface area, not its volume. That's weird, like all the stuff inside is actually stored on the outside skin. Later, a scientist named Juan Maldacena showed something even bigger. A 3D universe with gravity can be exactly described by math on a 2D surface. Not kind of like, exactly the same results. Our whole 3D world, including you, can be fully described by information on a lower dimensional boundary. Putting it all together. From these ideas, reality isn't local and real until measured from the entanglement experiment. Information in space is limited by surfaces, like a hologram. Space itself, distances, gravity, seems to come from quantum information and connections. This matches how a big computer simulation would need to work. It only renders, shows what you look at, saves memory by using surfaces, and creates the world as needed. A thinker named Nick Bostrom made a famous argument that at least one of these is probably true. Most advanced civilizations go extinct. They choose not to run simulations, or we are living in one. Physics gives the how. The universe acts exactly like a simulation would. The measurement problem, the big mystery. Quantum rules say tiny things can be in many possible states at once, superposition. But when you measure, you get one definite result. What causes that change? That's still debated. Some ideas say the observer, anything that measures or interacts, matters because it turns fuzzy quantum possibilities into solid classical reality. Not magic consciousness, but information being recorded. Experiments even show the past can depend on what we measure now, in a precise physics way, not change history with your mind. What this means for you. You're not just watching the universe. In this setup, observers like you help make the universe's official record real. Your attention and experience aren't extra, they're part of how reality gets written. This doesn't mean your thoughts magically control everything. It means you're deeply connected to it all. The big takeaway. The physics doesn't prove we're in a video game-like simulation run by aliens, but it shows our universe behaves in every measurable way like an information-based system that needs observers. Instead of making life feel fake or meaningless, it actually makes your experience more important. The universe needs things like you to become fully real. You're not an accident watching a show. You're part of the process that makes the show exist. And that's it for this one. Thank you for coming along on this mind-bending journey. This is Rand's Tall Tales, where we dig into the deepest science and physics, strip away the complicated stuff, and chase the truth that's hiding in plain sight. If this made you look at your hand, or the whole universe, a little differently, hit that like button, subscribe, and I'll see you in the next simulation.